Hello and welcome to StatLab StatCrunch videos. Today we're going to be talking about how to find the probability of a random variable that has been normally distributed with mean 50 and standard deviation 7. The way we do it is first we're going to find the z-score and then find the area under the z-score. But today we're going to go ahead and open up a StatCrunch. And it's open right here. Let's see. I go to my stats. Calculators, because it's a normal curve, I click on normal, and you have to look at it that this is a standard normal curve with mean 0 and standard deviation 1. So the mean is 0 and standard deviation is 1. So what you need to do is you need to go ahead and change this first before you go ahead and compute. So I'm going to go ahead and take a look at what my mean is. My mean here is 50. And my standard deviation is 7. So I'm going to go ahead and plug that in here. Mean is 50 and standard deviation is 7. And I'm trying to find the probability of x greater than 35. So I'm going to go ahead and change this to greater than 35 and compute. My area under the curve is 0.98393771, and if I go back and look at it, it is the same as the one I have. Okay, my areas under the curve match. So by using a StatCrunch, it becomes much more simpler. Now moving on to the next problem. In this problem, they gave us the mean as 83 and standard deviation is 5, and they told us the variable is normally distributed, but they're asking us to find the area between 66 and 79. So what I'm going to do is I'm going to go open up my StatCrunch here. Where is it? Okay, here's my StatCrunch, and when you look at it here, you will have to, let me move this over, because it's the area between, you got to toggle between standard and between. So this one has to be clicked. You have to click on between first. So let me go ahead and click that. There you go. And now, like normally, you have to go back and change your mean and standard deviation. The mean is 83 and the standard deviation is 5. And I'm trying to find between 66 and 79, and I'm going to click compute. When you click compute here, my area is 2.21151,847, and when I look at it, both my areas match. Alright, so that gives me the area under the curve. So the StatCrunch automatically calculates the z-score for you. Alright, moving on to the next problem here. It says use the normal distribution of SAT critical reading scores for which the mean is 500 and standard deviation is 123. And the variable is normally distributed. What percent of the SAT verbal scores are less than 500? So again, I'm going to go ahead and open up my StatCrunch. Stats, calculator, and normal. And here I'm going to go ahead and change my score to 500. The mean is 500 and standard deviation is 123. Less than 500. Sorry, less than 550. And I'm going to go ahead and click compute. And I have 65.78%. So when you zoom in, my StatCrunch gives me, let me scoot over so you can see I have plugged in my mean as 500 and standard deviation as 123, and I got my area under the curve is 0.6557, and this is what it's supposed to be. I'm trying to find the area for less than 550. So once you do that, you know the area is matched. But the next question is kind of tricky here. So in this question, let me close everything here. All right. In this question, they ask you if 1000 SAT verbal scores are normally selected, about how many would you expect to be greater than 525? Students usually get confused. They're asking you how many. They did not ask you the percentage. They did not ask you anything here. They're asking you for how many of them would you expect to be greater than 525. So they want you to give them a number. So the first step is to find the percentage of what percent of 1000 will be getting greater than 525. And because you know that it's a normally distributed curve, you're going to be using your StatCrunch for that. So let me go ahead and do that first. All right, so I'm going to go ahead and click on my StatCrunch. Stats, calculator, normal. Remember, you have to change your mean and standard deviation. My mean is 500, standard deviation is 123, and I'm trying to calculate what percentage of them would get greater than 525, and compute. When I compute, let me zoom this in really quick so you can see what's going on. When I found out the area under the curve, I get 0.419464. So this 0.41 is area under the curve. So what I'm trying to say is here, this value just gives you the percentage. This just gives you the percentage. So I have 41.95, rounding off to 2 decimal, 41.95% getting the value greater than 525. Remember, they didn't ask you what percent, they ask you how many. So if 1000 students take the test and 41.95% of them get greater than 525, that means out of 1000 students, 419 students get greater than score of 525, 41.95%. We're going to round it off. We can have 0.5, so it's 419 students take the test, get the value greater than 525 in the test. All right, hope this helps.